In this video, we are going to create the MouseInput helper class. In the last video, we had assembled a keyboard input helper that allows us to translate the state-based input over to event-based input. Now we're going to apply the same concept to the mouse. We're going to create a class that will feed out events based on when certain mouse events occur. So we'll have things like a mouse click occurring. We'll even have things like a mouse move or dragging and starting and stopping events. Now this class is going to be a little bit more complicated than the keyboard video because we are going to incorporate the idea of dragging. That is, the mouse class will be aware of a drag versus a standard move versus a standard mouse up. But we'll get into the specifics as we put the class together. To get things started, we're going to jump back up to our editor folder and add a new class. The class is going to be called MouseInput. And let me correct the spelling on mouse before I create it. There we go. And add. Now for our new class, we're going to begin with the same cleanup where we remove the editor sub namespace. We need to add some using statements for framework and framework.input, and I'm simply going to steal those from keyboard input. So we'll copy those and paste them into MouseInput. Now for the MouseInput class itself, we are going to mark this class as static. And once again, before we jump into the class itself, we are going to create some delegates. In this case, we have two different delegates we're going to create. One for mouse clicks and one for mouse movement. So let's begin with the first. We'll have a delegate. It will have a void return type, and we'll call this delegate mouse click handler. And mouse click handler is going to feed in a vector2 for position information. So I have vector2 position. And let me clean up just some visuals with the spacing. Now our second delegate is going to be used for mouse motion. Before I move on to it, let me do one thing, since we'll handle all of our parameters the same with lowercase values. Now I'll begin by duplicating this and changing the name to mouse move handler. So let me take the center, change click over to move. We are still going to pass in a position vector2 so we can see where the mouse is currently at as it's moving. But in addition to where we're currently at, we're also going to pass in a vector2 representing how much we moved, since in certain cases we may actually be interested in the distance traveled from the last update to the current update. So we're going to pass a second vector2, which we will call movement. And the idea is to perform the movement calculation inside of the mouse input class, rather than forcing the user of this class to record the position, wait for the mouse to move again, and sample the difference externally to the mouse class. Handling that internally will just keep things much cleaner. Alright, now we're ready to move into the mouse class itself. Inside of mouse input, we need to define some fields. So we'll start off with some private fields that will help us track mouse state here inside of the class. The first one is literally going to be a mouse state called last mouse state, which will allow us to sample button presses in the same manner that we sample key presses inside of keyboard input. So this will be a static mouse state field called last mouse state. Alright, in addition to this, we're going to store a vector2 for movement to allow us to sample the movement internal to the mouse class. So we'll make a static vector2 called movement. And finally, we will make a static Boolean value called dragging. Again, with movement, this will allow us to track how much the mouse has moved and gives a convenient value to pass on to the mouse move handler. Dragging is going to let us record the state of the mouse if we hold the mouse button down and begin to move the mouse. We're going to count mouse down plus mouse beginning to move as placing us in the dragging state. we're going to remember that state by setting this Boolean field so that later in time when other events occur, such as mouse up events, we can tell that we were in dragging and we need to do something different than we normally would in mouse up. Alright, so moving on from these state fields, we need to create some event handlers for things like mouse click, mouse move, and so on. So we will make public static events, or rather public static event fields. The first fields are going to be for various click events. So the first one we'll handle is mouse down. This will be of type mouse click handler, the name of course being mouse down. And just like we did in the keyboard input, we're going to create some anonymous methods so that we immediately link up our events. So we're going to make an anonymous method using delegate, passing in a method signature of vector2 position, and we will specify an empty method body using some braces. So that's all we should need to do for mouse down. Now we need to handle mouse up. So I will copy and paste the mouse down line to duplicate it, and I'll change the name to mouse up. And we'll leave everything else the same. We have the same delegate being passed in, same mouse click handler. The idea here is that we're going to look specifically at mouse down and mouse up as being two separate events. So that way we won't worry about added complications of what the mouse input thinks of as a click versus what the internals think of as a click. We'll simply keep the unique events separated as unique. So it's up to the user of this class to decide if a mouse down counts as a click or if a mouse down plus a mouse up counts as a click. We're going to keep everything clean and simple to aid in our selection code later on. Alright, moving on from here, we have two more events that we're going to define as click type events, and these are going to be used with dragging. So what we'll do is we'll begin by duplicating the mouse up event. So we're still using the mouse click handler, and we will make an event called start drag. And start drag is simply going to feed in the position at which the drag operation started. So this way we can tell the difference between the mouse moving and an actual drag occurring. So the moment we decide that in addition to just pressing the mouse, we're going to begin moving the mouse, we'll actually fire that as a discrete event separate from the other mouse moves. So if something needs to happen right at the beginning of the drag operation, we can catch that as a discrete event. Now, the counterpart to start drag is going to be end drag. So we'll duplicate the line once again, giving ourselves end drag as a mouse click handler with the standard anonymous method. Now there is one last event we need to put in place, so we'll duplicate this line one last time, and now we will change the delegate type to mouse move handler. And the name of this event is going to be mouse move. Now of course the delegate here needs an additional parameter in the method signature. So in addition to a vector2 position, we're going to add a second vector2 for movement. Like so. And again, this gets us ready to fire off mouse move events as the mouse moves from state sample to state sample. Alright, now we're ready to jump in and handle, actually one last thing before we jump into the method itself. There is one property we would like to add in addition to our state and events, and that is a property that will allow access so we can pull the mouse and ask if the button is currently down. Because just like we did with the keyboard input, we have the mouse state, but it is stored privately. We can't access that outside of mouse input. So we're going to give a property that gives access to mouse state so we can check and see if the left button is pressed. The reason we're doing this is so that we can still use the mouse input class in addition to things like the keyboard input class, where we can pull the mouse instead of waiting for an event to happen. So that way, for example, in addition to the Z key being pressed, we can tell whether or not the mouse is currently pressed at the same time. So to do this, we will make a public static Boolean property called isLeftButtonDown. And we will create a single get accessor, so we will have a read-only property. And inside of this getAccessor, we'll simply return whether or not the last mouse state's left button was pressed. So we will return last mouse state dot left button is equal to button state dot pressed. So we will terminate this terminate this column, and then add 2 closing braces to close off the property itself. So what we're actually doing here is just an inline operation where we're checking left button, since left button is actually a button state, it's not a Boolean. So we run the operation left button equals button state dot pressed. If that operation returns true, well, that passes through nicely to our Boolean property, and so we can easily tell whether or not the button is indeed pressed. Alright, now we're ready to move on to methods. In the MouseInput class, there's only going to be one method, just update. Because we don't have any kind of initialization, we don't have to worry about lots of different buttons. We know that we have the mouse information provided by X and A, and that's it. So all we're interested in is what happens to the mouse update by update. So we will create a public static method, void return type, called update. Then inside of update, we're going to begin with some local variables to help us track the various information of the mouse itself. So we're going to begin with a mouse state variable. We'll call this variable mouse state, and we will sample the most current mouse state from mouse.getState. Now, before we worry about anything else inside of update, we'll create our differentiation between current and last by making sure that we remember to update last mouse state to be equal to current mouse state before we do anything else. So once again, we establish that anything happening between these two lines is going to let us tell the difference between current and last. Now, in addition to the mouse state, we're also going to create some vector-based positions based on the mouse itself. This will make later calculations a little bit easier and more straightforward to read. So we'll begin with a vector2 variable, and we will call this variable current position. And current position will be a new vector2, and we will simply assemble the current mouse state's position into a vector2. That means the x component is going to be equal to mouse state.x, and the y component is going to be equal to mouse state.y. Now, in addition to current position, we also want to have last position readily available. So I'm going to duplicate this line and change the name to last position, where we will sample the last mouse state rather than the current mouse state. So last mouse state.x and last mouse state.y. Alright, now that we have some positional information ready for use, let's turn our attention to firing off some of the mouse click events, beginning with the most simplistic, mouse down. In order to detect that a mouse down has occurred, we'll look at the current state of the left button, and if it is pressed now and was released in the last state, it has just become pressed. So we'll put together an if statement, and we'll check and say if mouse state dot left button is equal to button state dot pressed, and our last mouse state dot left button is equal to button state dot released. In this case, we're ready to fire off the mouse down event, because we've just gone from, in our last state, we've gone from released to pressed, indicating a mouse down. So that means we can fire off the event mouse down and pass in the current position. So we'll simply take the current position local variable and pass that along to mouse down, because that was the position at which this event occurred. Also, since we're going to have a few more conditions for this if statement, I'm actually going to extend it to have curly braces on all of its conditions. So even though mouse down is a single line, we'll put it in braces, and that'll make it flow more naturally with the remaining statements. So if the mouse has not just been pressed down, we'll do a check to see if possibly it has been released. So I'll begin by copying the if statement, checking for a mouse down, pasting it in place, and changing the order of the checks done. So on the current, instead of looking for pressed, we'll be looking for released. And on the last mouse state, we'll be looking for the left button to be equal to pressed. So looking at last, if we've gone from pressed to released, we have just released the mouse button, and we need to fire off a mouse up. So let's brace this code in place. And even though we're going to have a more interesting scenario when we put dragging in place, but just to get this started in a more simplistic fashion, let's fire off the mouse up event. So we have mouse up and use the current position as the parameter fed to mouse up. So again, this code is very much like keyboard input, only minus the presence of an is button down method. So, looking at our code now, let's introduce the idea of mouse movement. Now in the case of mouse movement, we want to be careful about exactly when we call the mouse move event, because it's attempting to just say here inside of update, every time we call update, fire off mouse move. The problem is we don't want to fire mouse move events when the mouse hasn't actually moved. We never want to fire off a mouse move event where the movement is equal to 0. So first, let's calculate the movement and then check and see if we should fire off an event. So we'll take the movement field we created earlier and set that to be equal to current position minus last position. And looking at our tooltip did not help us out there as much as I'd hoped. We grabbed last mouse state by accident. Let me correct that to last position, and that will give us an appropriate vector 2. Now we can turn around and say if movement.length is greater than 0, then we'll brace in the if statement. We can say that the mouse has indeed moved on this specific update. So we're ready to turn around and fire off an event. Again, this will get a little bit more complicated when we put dragging in, but in a simplistic fashion, all we would do would be to fire off the mouse move event, passing in first the current position, and second the mouse movement. So this would work very well for detecting mouse down, mouse up, and firing off mouse move every time the mouse moves to a different location per each update, but only sending the event if the mouse has indeed moved. Now, we need to address the concept of dragging as well, because we have to satisfy the events for start drag and end drag, and we have an interesting handling of mouse up that will be used as we put these together. So, looking here inside of our mouse move code, let's put together the necessary code to detect what dragging is. We're going to define dragging as the action of the mouse moving while the left button is pressed. So basically, we have to sample a movement and note that left button is currently down. And if that's the case, then we will go ahead and invoke the dragging code. So what we'll do is before we fire off a mouse move, we'll put together a check that looks at mouse state and checks to see if left button is currently pressed. So equals button state dot pressed. And in addition to this check, we'll also make sure that we are not already dragging. So we'll say and not dragging. Because the idea is that with start drag, we want to only fire that when a drag operation begins, not continuously as it updates. So we want a section of code that's only going to fire once per drag. So here inside of this if statement, as soon as we've noted that the mouse A has moved, looking at movement.length, B, the left button is down, and C, we're not already dragging, in that case, we will begin a drag operation. The first thing to do is to remember that we are in a dragging state, so dragging will be set to true. In addition to this, we will fire off the start drag event. And start drag needs the current position, so we'll feed in the current position variable. And that takes care of detecting and beginning a drag operation. Now, moving on from here, we need to take a look at mouse move, where it fits into the equation, and drag end. So, if we are if the button is down and we're not dragging, then we need to perform a mouse move. So really looking at this, the code is already structured properly, because regardless of whether or not a drag started, we still want to fire off move, even if the drag has just started. So we fire off, that means the moment the drag begins, we fire off start drag followed by mouse move. For remaining movements of the mouse, we're already dragging, so we don't re-enter this code and continue to fire off mouse move. So really we get mouse move events whether we're dragging or not. Now we need to address how mouse up should be handled with our dragging. So going up here to mouse up, we're going to first do a check before we fire off the mouse up event. We're going to see if we are currently in the dragging state. If we are in the dragging state and the mouse is released, we will fire off the end drag event instead of the mouse up event, and I'll explain why here in just a moment. Also, if we were dragging and released the mouse, we need to remember that our dragging has ended, so we need to make sure that we reset the dragging field. So the first thing we do is say that dragging is equal to false, because a mouse up ends the dragging operation, and we need to fire off an end drag event giving in the current position. Now, only if we were not dragging and the mouse is released will we fire off the mouse up event. So we'll actually put mouse up in an else clause. And just to make this very clear what's happening, I'm actually going to brace this in fully, even though it's only one line. So we can say if dragging, note the dragging state, change it, and fire an end drag, otherwise fire a mouse up. And the reason for this is we're going to differentiate between the end of a drag and a mouse up event. When we get into performing selections, a mouse up could very often result in deselecting items. You can think of anything, even icons within Windows, or even this selection here within Visual Studio. As you click on things and mouse up, very often that will cause a selection to be dropped. If you have 10 items selected, you click and release on one of those items, you have only one item selected. So we want to differentiate between these two, since in the case of a drag operation, you don't want to move multiple objects and then have those objects deselect the moment you let go of the mouse. You want to retain your selection. So we're going to treat the end of a drag differently than a mouse up. And that's just one key I wanted to point out, since in our movement code, mouse move happens regardless, versus mouse up, where it only happens if we're not dragging. But this one simple differentiation will make it much more simplistic to implement selection and moving in our scene editor. Alright, with all of these in place, let me do a brief build, make sure everything gets saved, and we're not showing any syntax errors. So that should take care of the MouseInput class. Again, we've gone from the world of state-based input provided by XNA and created a wrapper that will allow us to handle the mouse in event-based tracking. So with that, that is going to wrap up this video.